So in this case, we are simply going to consider an exam, which is on our statistics. Remember, we managed to work out the basics now with our grade 10 mathematics and all that we had in our grade 11. You must be able to answer any question that you are given, which is under statistics. So we are given on question number one, that is the data below from the information that we have, that is the data that we are given. It is the annual report. So that is a yearly report annually from the local municipalities regarding the spending of money in what? In thousands of rands. So whatever that we are given is in thousands of rands on electricity. So with the table that we are given, this is ungrouped information or ungrouped data. As we can tell, information is just randomly given. We are not given this in terms of intervals 1 to 5 or something like that. We are not having such consideration. So the first thing is to consider here is the order that we are given of these numbers. Are they in the order of size? Before we can attempt our questions to draw the box and whisker diagram, to calculate the standard deviation, yes, these ones we can just, but the box and whisker part. First, let's consider the order. As we are going to be dealing with the quartiles, we must have the order of size. All right, so the numbers, they are not in the order of size. So we must arrange first in the order of size. That is according to the given numbers, the least value or the smallest number that we have here is 250. So first of all, we have to rearrange. All right, let us rearrange. So the first one, that is 250, which is followed by 259. So we have got 259 followed by 266. All right, so we have got 266. We also have 277. All right, so this is 277. We have got 287, 287. So that's 287. Another one, 287 again. Then followed by 294. All right, we have got this 294. And we also have 306. All right, 306. So we must consider there the order of size. 315. All right, we also have 329. All right, so this is what we are given. These are the given data values which are being arranged in the order of size so that we can determine the 5-number summary which is needed on the box and whisker diagram. All right, so let us consider our 5-number summary. As we have, we're gonna need the minimum value. Okay, the minimum value, which is 250. We're gonna need the first quarter, which is the lower quartile. So first, the position given any distribution, position first. So how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equivalent to what? To 10. We are dealing with 10 terms. So the position of our Q1 first, its position. Each and every case, you must determine the position. So that's a quarter of what? N plus 1. So guys, there are so many adjusted formulas that you can use. But with the principle of this formula, it is a direct. We're just going to need to know how to determine your answers later on. So our n being 10, we can substitute. All right, so that's a quarter of what? So I just want you guys to quickly work on this one. So that was going to be 10 plus 1. That's 11, and a quarter of 11 is going to give us something like 2,75. All right, you can have our calculator. That is 1 over 4. All right, so we've got 1 over 4 of what? 11, like this. So that was going to give us what? 2,75. So I said from our grade 10 mathematics, when given a decimal position like this, it's a decimal, you look into the given number after 2,75. Our comparison is supposed to be at 2,5. Comma 5 is our comparison. At comma 5, meaning to say you look into between the given numbers, between the whole numbers, between which whole numbers is this number found when it is at 2,5. But when it is 2,75, it is 2,25, we must round off to the nearest whole number. Be very careful when it is like that. Round off to the nearest whole number. So guys, there are so many ways, but when you are using this method, right, this formula, you have got a 2,75 like this. You round off to the nearest whole number. So 0.75, as we can see, it's bigger than 0.5. So meaning to say it's going to change this one into 3. So that's the number that we are going to need is going to be on the third position. You round off. So that's the third position. Third position. So we're going to count 1, 2, 3. The third position. The number that we are given there is what? 266. The third position. So that's 266. The third, you round off. At 2,5, you take in between the second and the third value when it is at 0.5. So you must compare with 0.5. Your comparison is on 0.5. All right, so let's look into another part, which is now the median value, the second quarter, which is Q2. All right, so there, just going to consider Q2 value. So first of all, the position, all right, which is a half. So this one is a half of this. That's half of what? N plus 1, which is 10 plus 1. So that was going to give us something like 5,5. As we can see, we are dealing with 0.5. 5,5. So the 5,5 here, 0.5 here, that's in between. You are not going, in this case, you do not round off. You are at that exact point of comparison at 0.5. So you take in between this number, 5,5, I mean that we are given, it lies in between which two integers. So it lies in between the fifth value and the next one, which is what? The sixth value. So it's going to be between 5 and 6. 5,5. It is between the fifth and the sixth value. So when it is another decimal 5,75, it's no longer at 5,5. That is where you round off. 5,25. Let's say it was 5,25. You round off to the nearest whole number. It does not change. It just remains as what? 5. 5,75, it changes to 6. But at 5,5, you look in between. You are at that point of comparison, remember. So you look in between. So that is your revision, guys. Just make sure you go through your recap, the notes, everything, so that you can understand all these. All right. So that is what we're going to have. Let us quickly have this between the 50 and the 60, meaning to say we are going to add these numbers. All right. So that's 1, 2, 3, 4, 5. So the fifth value is this one. The sixth value is this one. So in between. We need in between the 5th and the 6th. In between. So you're going to simply add 287. All right, so you're just going to add these 287 plus 287 over 2. So guys, as you can see, that was going to simply give us the same answer of what? 287, the same value, I mean. So that's 287. This is what you're going to have. So that is the major part. At comma 5, you look in between the given numbers, the whole numbers. Then we have got the third quarter, which is our upper quartile. Okay, this is upper quartile, which is Q3, which is according to the position. That's 3/4 of what? Of the distribution. So that's 3/4 of n plus 1, which is 10 plus 1. Okay, so that was going to give you 8,25. 8,25. As we can see, it is not at 8,5. Our comparison, comma 5. It's not there. It's less than that. So, comma 25, is it going to change this? Because we are supposed to round off when it is like this to the nearest whole number. So, comma 25 cannot change 8. It is less than comma 5. So that is not going to change 8. It is going to remain as 8. So we are going to focus on the 8th position, 8th value. According to this, it does not change, you round off. But if it was at 8,5, you look in between the 8th and 9th. More than that, it changes to the 9th position. If it is more than 8,5. Less than 8,5, it does not change. It remains as 8, like that. At 8,5, you look in between the numbers. So that is it. So here we are going to look at the 8th position. So remember, this is the 6th position. So that's the 7th position, the 8th position. So the number that we want there is 306. All right. Then we also need the maximum value of the given data or information, which is what? 329. So this is what we have. 329. These are the numbers that we are going to represent on our box and whisker diagram. So actually, under exam condition, guys, you're not, if you know these basics, you're not supposed even to spend much time on this. Just quickly work out your values. All right. Then present those values on the box and whisker as we are given the presentation. So they said on this part, we are supposed to represent. So as we do understand the minimum value first. So the minimum value, that was 250. All right. So we've got 250 here as our minimum value. So that's 250, which is at this point. All right, let us just try to have just a line here, okay, that can direct us to that 250. So something like this. Okay, so this is at 250. Okay, at 250, guys, where am I putting this one? We need 250, not 255, but 250. Okay, which is here. So that's our 250, meaning to say we're just going to have the presentation of the minimum value. Then we're going to need Q1, which is the starting part of our box, which is at 266. So that's 266 can be somewhere approximately, let us just approximate somewhere above 255, somewhere there. So we're just going to approximate somewhere there above 265. So we know that is where our Q1 is. So that is the starting part of what the box in this case. All right. So we're going to have our box going this side. All right. This is connected here. So that is at what? 266. Another value which is important is Q2, but let's ignore it for now. Let's go to Q3, 206, 306, which is approximately at this point. All right. There we're just approximating, guys. So that's where we are having our 306, 306. So meaning to say the box is going to be completed at Q3. All right, that's where we complete our box. Remember, this is our Q1. This is our Q3. And we have got the Q2 that we left, which is what? 287. So where is our 287? 287, we're just going to also approximate. This is somewhere here. Okay, somewhere there. So that's at 287. So you're going to need this one straight. So that's our Q2 at what? At 287. So this is the most important part. Then to the maximum value, which is the last one, 329. So the maximum value, 329, just approximately somewhere there below, just before the 330. So just somewhere here. So we're just gonna approximate to say maybe it was somewhere there. So meaning to say we can join this whisker to the maximum value. That is the last part that you are going to have. All right. So this is it. Just like that. So these questions, they are direct. You just need time to work out as many questions as you can. So this is at 200 and what? It was 329. 329. This was at what? Direct 250. So we have got our box and whisker. Then from there, we are being asked to comment on the skewness of the data that we are given there. That's 1.2. Comment on the skewness of the data. If we are to look into the diagram, our box and whisker diagram here, we can see it's a weird part that a conclusion is difficult to actually make here. Because if we look at the position of our Q2, where it is there, yes, we have got a bigger, or this side, which is bigger to the right compared to this one of the left. But if we look deep into the diagram, we can see that the Q2 is somewhere in a midway. If we check, it is somewhere in a midway. So thus, let us have a comparison from the mean. Remember the condition of the mean and the median, the comparison that we can make between these two on the skewness. Since we have got the data values, we can just use our calculator, guys. Let's find the mean. Add the terms, divide by what? By 10. Or we can use our calculator since, okay, let's check if there is any part that, all right, here, if you check, they also want you to calculate the standard deviation later on. So guys, let us just use our calculator to calculate the mean. As we do understand, where the mean is, the standard deviation is also. So let us put these values into the calculator. So remember, we're going to need first the mod, then go to state, which is number 3. Then number 1, all right, let's insert our values. 250 is equal to 266 is equal to 277. You insert In whatever way, even those ones that we arranged in the order of size, guys, even from the table, it is up to you. So there's another 287, all right, 259, 306. We also have 315. We also have 294. We also have 329. Okay, so this is what we had. Then cancel this, go to shift, then number 1 on state, then number 4, all right? Then the mean, which is number 2. So that's equal to 287. As we can see, the mean of this distribution or the data that we are given is 287. The mean is 287. If we go to this part of the median part, our median is 287 again. So we can see that the mean and the median are exactly the same. So therefore, it is a symmetrical. You could have also worked from the mode. Remember, we said the mean mode will be the same. The mode is also 287. That's another thing to compare. So this type of a question, it was not only something that you consider on the diagram. The information, what is it that we had before? Remember what I said before. So meaning to say when it is like this, we can say it is what? A symmetrical. It is symmetrical. The condition that we are having there simply tells us that it's what? It's symmetrical, as we have got the mean, the median being equal and also being equal to the mode. So that's a symmetrical that we have. Then 1.3, calculate the standard deviation. So already you have inserted your information on your calculator. So just cancel here, go to that part, shift number 1, then number 4, then number 3 for the standard deviation. That's number 3, which is equal to. So already the standard deviation is there. We can even round off to 2 decimal place. Let's fix to 2 decimal place, 23,77. So the standard deviation is already there. That's 23,77. Okay. Just like that. Then we move on to another part, 1.4. How many municipalities are within one standard deviation of the mean? Within one standard deviation. All right. Also, guys, I referred to this one or talked about this one separately as a class. Remember, I said when it is within one standard deviation of the mean, you must consider the mean minus one standard deviation, all right? Then another part, the mean plus one standard deviation. So the other part is going to be one standard deviation being added. So it's 1, this is 1. So 1 does not even affect. They can say 2, depending with the question. You insert the numbers there. So it is within this interval. It is an interval that you must consider within that interval. So let's check, guys. We already have our mean 287. So the first part, just going to insert here 287 minus one standard deviation, which is 23,77. Then the other part, we must add the mean to one standard deviation. Our mean of 287. All right, so that's 287. We add this one to one standard deviation of what? 23,77. So this is the case. Within. So the first part, we were going to have, if we are to simplify this one properly, that was going to give us 263. That's 263,23. Okay, up to, if we add this one, that's up to 310. comma 77. So we are saying the numbers or the data that we need is from 263,3 up to this. So we need anything in within that, in between. So let's go to that part where we had these in the order of size. Remember, we managed to rearrange our numbers in the order of size. So if we are to check from this side, we are saying we need numbers. They did not say list them. They are saying how many are they? How many? So you must list them down between 263. So this is 266. So maybe 263 is somewhere there. 263, comma, it was 263, comma 23. It can be somewhere here. So meaning to say we need from 266, we're going to take this value. It's more than, it's greater than 263. But these values, they are supposed to be taken up to what? The limit. We are limited, guys. We're not going to take anything that we want. We are limited up to 310,77. So where do we have 310 on these numbers? 310 is going to be approximately below 315. So let's say this is where we've got 310,77. So we need numbers that are below that, these ones that are going this side. Here, that are more than 263,33. These numbers going this side. So in between, these are the numbers that we have. 266, 277, 287, 287, 294, 306. But the question is, how many? How many? Count them. You are not asked to list the numbers which lie, but count to say how many are they. So that's 1, 2, 3, 4, 5, 6. So there are 6 of them. So therefore, we are saying there are 6 municipalities that we are given there. There are 6. All right. So there are 6 of them. The municipalities. The municipalities. All right. So that is the idea of answering these questions. That is the major part. Okay. Then on the other hand, we are given to determine on 1.5 the semi-interquartile range of the municipalities. The semi-interquartile range. So as we do understand, the semi-interquartile range becomes an average of the interquartile range. So what am I trying to say here? All right, remember we had, okay, it's only that I have erased 1 or 2 from this part. But anyways, still remember the values that you determined on that 5 number summary. So you're just going to use that part. All right, so this is 1.5. So like I was saying, the question is we need the semi-interquartile range. So the semi-interquartile range is just an average of the interquartile range. So that's half of the interquartile range, which is Q3 minus Q1. So remember, Q3 minus Q1 represents what? It represents the interquartile range, this one. So we need in between, we need average of that. That's the semi-interquartile. So that is half of. We calculated Q3 before, that was 306. All right. We also calculated Q1. Remember, it was 266. This one, it was 266. So that is half of this. That was going to give us what? 20. So we have got 20 of the local municipalities that are in the semi-interquartile range. So that is how you can answer these questions. All you just need is to work out as many questions as you can just try to work out the basics. All right, as an individual, you work out the basics, as many questions as you can, as you are preparing yourselves for the exams that are ahead of time.